All right, you guys, we're going to be working through the test review. Now, be aware I'll probably be working a little fast, so don't be afraid to pause, rewind, and rewatch this video as many times as you need so you know how to do each and every one of these problems. All right. First off, first object, we're classifying here the name of the polygon. All I know is it's got 4 sides. I don't know anything else. That's a quadrilateral. Convex or concave. This does not cave in on itself, so it is convex. I don't know the sides are the same. I don't know the angles are the same. Therefore, it's not regular. So this is just none of those. Okay. This object's different. It's got 6 sides. That's called a hexagon. This one is also convex. I know all the sides are the same, but I don't know anything about the angles. So I have to say equilateral. If I knew the angles were the same, I would put regular. This, if you look at the definition for a polygon, needs to be one enclosed space that's connected at the endpoints. This is not a polygon, so I'm not going to answer any of those questions. Okay. Find the sum of the interior angles. Immediately, I know I need to be using my formula, n minus 2 times 180. It's got to be a convex 14-sided polygon, so I'm going to plug 14 into there. 14 minus 2 is 12. 12 times 180 is 2,160, and I need the sum so that I can stop there. Surface of trampoline is a regular. I know it's equilateral and equiangular. 8-sided figure. What is the measure of each? Now I'm going for each. I can find what they all add up to, again, using my formula. Number of sides, minus 2 times 180. 8 minus 2 is 6 times 180. I get the sum is 1,080, but I want to find each one, so I got 8 of them. Divided into 8 equal pieces. I'm looking at 135 degrees, just to make sure this is interior, so I'm right, 135 degrees. Here, now we're moving to exterior angles. I know all of these have to add up to 360 degrees, so I'm going to take them all and add them up. 7z minus 5 plus 5z plus 10 plus 4z plus 4z plus 15, add them up. They got equal 360. So the number of z's, I got 12. 16, I got 20 z's. Minus 5, that's a plus 5. Plus 20 equals 360. Take away 20 from both sides. I'm here, and I divide both sides by 20. Z is going to be 17. And I'm supposed to find the measure of each angle. So I need to plug 17 back in. All right, 4 times 17 gives me 68 degrees here. 7 times 17, this one's 114. Didn't need a minus 5. Oops, I want to do 5 times 17 plus 10. I got 95 degrees here. Hopefully I'm getting that right. 4 times 17 plus 15. There's my 3 angle measures. 1, 2, 3, and 4. Here, if I want to find each exterior angle of a regular hexagon, all I got to do is, I know they add up to 360, and there's going to be 6 of them. So each of them is going to be 60 degrees. Page 1, done. Just going to make this one entire video, but I'm trying to go nice and fast. Okay, you guys? All right, I got a parallelogram. CD is 20, BE is 9, and angle DAB, this entire angle is 50 degrees. So BD has got to be 9 times 2, which is 18. AB is going to also be 20. DE, I know that's 9. Angle ABC is this angle over here, which I know is supplementary with the 50 degrees, so that's 130 degrees. BCD is going to be the same as 50. And CDA is going to be the same as 130. Another parallelogram. PS, I want to find the value of PS. I know that this side's got to be equal to the one across. 7y plus 3 has to equal 4y plus 15. And now we're just solving. Take away 4y on both sides. Take away 3 on both sides. If I divide both sides by 3, I get y is 4. So if I plug 4 back in, that's 28 plus 3, 31. QR is going to be the same. And I got these two angles that are next to each other. I know they have to add up to 180 degrees. So I'm going to do some adding in my head real quick. 8x and 3x is 11x's. Negative 7 and a positive 22. It's going to be a positive 15. They have to add up to 180 degrees. So I'm solving again. Divide both sides by 11. I think that's 15, but we'll check it is 15. X is 15, but I need to find angle P. That'd be 45 plus 22 is 67 degrees. And 8 times 15 is like 120. Take away 7, I got 113. That makes sense. Show. Now this one I got to show that it's a parallelogram. Well, if I know that I already got the values of x and y, if I plug in, I'll know the lengths of the sides. I just got to prove that the opposite sides are congruent. That's one of the conditions. So if I plug 3 in here, I get 41. I hope I get 41 over here. 24 plus 17 is 41. Those are equal. Now plug in y. 54 minus 30 is going to be 24. 9 plus 15 is 24. Those are also the same. I do have a parallelogram. The opposite sides, both pairs of opposite sides are congruent. Slab of concrete supported with diagonal spacers. First off, it's a rectangle, so I get all those goodies. CN is 30. NT, the distance all the way across, is 52. So the only way to find a TR is the easy one. That's 30. ER, actually, that's not that bad because if it's a rectangle, the diagonals are congruent. They're both 52. If you cut it in half, 26. That could have been more difficult. They could have asked me a Pythagorean theorem problem and had me go after that, but they're nice. Didn't have the tough problem. All right, again, make sure every time you notice what shape you're dealing with. A rhombus and all the sides are the same. That means this side and this side are equal. Add 14 to the other side. That'll give me and minus 3a. A is 14. Then I want to find ys. There's nothing there, but all the sides are the same. Plug 14 anywhere I want. I get 42. Every side's got to measure 42. And if they want to know QYR, I know this angle, QYR, it's got to be the same as this one. And this entire angle is supplementary with 178. That means this entire angle is 102 degrees. Cut it in half, and I got my 51. We're doing good, everybody. One page down, one to go. To Determine if each quadrilateral is a parallelogram. Make sure you have your conditions sheet. Yes, this is one pair of opposite sides is both parallel and congruent. If parallel lines, this is not one of our conditions, and neither is that. I got a rectangle. RT is 55. QR is 45. They want to know what is PR since it's a rectangle. Cut it in half. RS. This is the tough problem. So 55, 45, and question mark. There is a right triangle here. That means Pythagorean theorem is a possibility. I don't know, squared plus 45 squared has to equal 55 squared. See that right triangle that exists. So if we square each of those, that's supposed to be a square. So actually 45 squared, take the first number times the next one. There's a little trick here. 4 times 5 is 20, and it always ends in 25. 5 times 6 is 30, and it always ends in 25. Minus this to the other side. A squared is 1,000, square root both sides. And I get about 31.6. QS is going to be 55, and QP is again half of 55. All right, I got another rhombus. I know all the sides are the same, so these have got to be equal. 9a minus 10 has to equal 5a plus 6. Add 10 to both sides. I got 4a on the left, and I got 16 on the right. Divide both sides by 4, and I got a is 4. If we got to find yz, that's just another one of the sides. They're all equal, so I just got to take 4 and plug it wherever I want. This is the easy one. 5 times 4 is 20, plus 6, 26. Looks like the same rhombus problem, but now we're doing the angles. A little bit more difficult. WXZ. WXZ is what we want to find out. If XYZ, oh, they want us to find that as well. But YVZ, this angle, if it's a rhombus, I know this is 90 degrees, and they gave me an expression. So just take that expression, 7b plus 27 equals 90. As you can tell, you better have a good lock on your algebra skills. That is 63. Divide both sides by 7. B is going to be 9. Now to find some angle measures, got to start plugging some stuff in. WYZ, this half over here is 3b plus 7. 3 times 9 is 27 plus 7. If this half is 34, the whole angle, this angle is going to be 68 degrees. WXZ, this half, I know if this whole angle is 68, the angle next to it is the rest of 180 degrees or supplementary. That'd be 112. Cut it in half. That means this angle, 56 degrees. Again, stop, pause, rewind if you need to. I know I'm working very fast. but I'm writing it out, so you should be able to take it as slow as you want. All right. Ooh, kites. I love kites. All right. The angle NQP, we got 70 degrees right there. NMQ is 60 degrees here. I know all of the angles right there in the middle are 90 degrees. NMQ, this whole thing was 60 degrees. So NMR is going to be half of that. MQR, I know that this is 30 degrees and 90. That means this part is 60 degrees. Because the angles inside of a triangle have to add up to 180 degrees. And a kite is symmetrical, so we can move all this stuff up here. This is 60, this is 70, this is 90. They want to know NPR. 70, that's got to be 20 degrees there and there. MQP, I just got to add up 60 and 70. Last page. All right. This, I don't know if you remember, this is actually a problem from the past. This is referred to as a midsegment. Midsegment. If you don't remember it, the midsegment, anything we cover throughout the year as fair game, is the average of the top and the bottom. Well, if the difference here from 10 to 18 is 8, then that means this has got to be right in the middle, 14. Blast from the past, but very doable. And the ever scary proof, they're going to start with the given idea. They gave us a whole bunch of rhombuses or rhombi. And then we got a bunch of points here in the middle that are midpoints. So the question is, why does BC have to equal DC, which equals WX, which equals WZ? Those are pieces of congruent rhombi. That would be the definition of congruent rhombi. Then if we start looking, why would BM plus MC have to equal BC? That's a good old segment addition postulate. And if you see, we got BC here and here, we got DC here and here, WX, WZ. They're going to replace all of that with this stuff to make this step. Replacement means substitution. Then we got to start to see, why would BM have to equal MC? Why would WM have to equal MX? That's because of this midpoint idea I told you a minute ago. This is definition of a midpoint. And then number 4 and 6 look a lot alike, except this changed into this. This changed into this. They're just doing a whole bunch of different substitution moves. And then they're going to combine like terms or simplify the situation. And they're going to get rid of all those 2's. The only way to do that is to divide it out. That's the division property. And believe it or not, if all of those things are equal, if this and this and this and this are equal, that little guy in the middle, that's definition. We have satisfied the definition of a rhombus. I know proofs are scary, but try and understand all the statements were given to you. The skill is actually trying to read of what the conversation going on and trying to understand the conversation. All right, that you can do. I promise you. Good luck. Get it all done.